Standard cycles. Now, practical gas cycle power cycles are complex. We simplify our analysis by making the following approximations, assumptions actually, which are known as standard assumptions. The first assumption A, the working fluid is an ideal gas. So, ideal gas law is applicable. The specific heats Cp and Cv are constants. The cyclic process is reversible. There is no dissociation at the end of the heating process. Circulating mass of the working fluid is constant in the cycle. Addition of heat to the cycle is done by an external source. Rejection of heat by the cycle is done to an external sink. There is no change in kinetic energy and potential energy. Okay. Now let us define some terminologies. It is related to IC engine. First one is bore. The inner diameter of the cylinder is called bore. Top dead center, TDC. The extreme position of the piston at the top of the cylinder head side is known as top dead center, TDC. In case of horizontal engines, this is known as the inner dead center, that is IDC. Okay. Now this is the figure. This is the cylinder and this is the piston. Actually piston is this one is the piston. So this is the crank radius. Now when it is here, so it is going to the top extreme position of the cylinder. that is top dead center. In case of horizontal engine, it is known as IDC, inner dead center. Okay. Now, when the crank is rotated and it is in this position, this is called the extreme lower position, that is the bottom dead center. And in case of horizontal engine, it is called ODC, outer dead center. Okay. So this is bottom dead center. I have already told you. Now this is the explanation. The extreme position of the piston at the bottom of the cylinder is known as bottom dead center, that is BDC. In case of horizontal engines, this is known as, what is that? Outer dead center, ODC. Okay. Then come to stroke. The distance between the extreme positions of the piston, that is the distance between two dead centers, is called the stroke length. So stroke length is equal to double the crank radius. Okay, that means if the stroke length is L, it will be equal to 2 into R, crank radius. Okay. Now what is the stroke? Stroke is from here to here. This is a stroke length. Okay. Now swept volume. The volume swept through by the piston in moving between top dead center and bottom dead center is called the swept volume and is denoted by Vs. Swept volume Vs will be equal to pi by 4 into d square into L, where d is the cylinder bore, diameter of the inside diameter of the cylinder, and L is equal to length of stroke, that is the 2R. Now clearance volume. The space above the piston TDC is known as combustion chamber space, and its volume is called the clearance volume and is denoted by Vc. Volume of the cylinder. It is the sum of the clearance volume and swept volume. That is equal to cylinder volume will be equal to V. That is equal to Vc plus Vs. Compression ratio. The ratio of the total volume of the cylinder to that of the clearance volume is called the compression ratio R. So R is equal to, this is the total volume divided by the clearance volume. Total volume is equal to Pc plus Vs by Vc is equal to 1 plus Vs by Vc. Okay. Compression ratio varies from 5 to 10.5 in SI unit, SI spark ignition engine, and 12 to 25 for CI compression ignition engine. Mean effective pressure PM. The mean effective pressure represents the theoretical constant pressure for which the work done during volume change Vs is the same as net work. Now this is the actual, for example, this is the 1 2 3 4 1. This is the stroke volume, and this is the clearance volume. So what will be, this is PV diagram. What will be the PM? If this area is equivalent to a rectangle, the one side is Vs and another side is PM. So that is this PM, this is a PM. So PM into Vs will be equal to W. So W net is equal to PM into Vs. Okay, that is the PM will be equal to W net by Vs. That is the net work done per cycle divided by the swept volume. Okay, now I think you should know all this. Now this is the combustion chamber. This is the valve 1. This is the exhaust valve, and this is the intake valve. Now this is the spark plug. This spark is created in this combustion chamber. This is the piston which is moving, reciprocating in this direction, in this way. This is the bottom dead center, this is the top dead center. Now this exhaust gas goes in this direction, and this is intake manifold. This is a stroke. Okay. Okay. Now then come to the Otto cycle. Okay, we will be discussing the Otto cycle in the next video.